Okay. This video is going to be a refresher on viewshed analysis. If you remember from class, viewshed analysis refers to the ability of an observer on an elevation surface to see or not see certain parts of the landscape. Now, it's essential that this observer is placed on top of a digital elevation model so that we can understand from the location of the observer and the height of the observer what is and isn't visible. The observer could be a person standing on a landscape, it could be a cell tower, it could be a wind tower, or in this case, it could be the view from the top of Johnson Tower. Let's go over to QGIS and take a look at our data. In our data here, we have our elevation, our DEM for Skidmore. As you can see from the contour lines that I've overlaid over the top here, Saratoga is actually pretty flat. These are 5-meter contour intervals. But as soon as we get outside of Saratoga to the northwest and to the east, it gets much steeper. We have Johto, Johnson Tower location right here, and we have our boundary of Saratoga. To run our visibility analysis, we need to install the visibility analysis plugin. We can do that by going to Manage and Install Plugins, searching for visibility, highlighting it, and clicking Install Plugin. I've already installed it here. We then get a new set of tools in our visibility analysis tools within our processing toolbox. Our first step is to create viewpoints. We do this by inputting our point or line-based data from which we'd like to generate observer viewpoints. I'm going to select Johto. I'm going to select my toga elevation. My radius of analysis is 10,000 meters. Observer height is 44.5 meters, the height of the top of Johnson Tower. My target height, 1.6 meters, so about person height around Saratoga. I'm going to save to file as Johto observer. Shapefile, I'm going to click run, and then close. A new point should have been added to my map up at the top here. My next step is to run the Viewshed tool itself. This Viewshed tool takes the observer locations, a digital elevation model. We can take into account Earth curvature for large viewshed distances, and for multiple outputs, if we have multiple observer locations, we can specify the math we'd like to see for those outputs. Now I'm going to save this file again as toga viewshed. It's a TIFF file. I'm going to run. And the output of this viewshed should be values of 1 and 0 for my study area. Values of 0 will be areas not visible at the observation point. Values of 1, my observation point here, values of 1 will be areas that are visible. I'm going to go to Layer Styling and select Paletted Values. I'm going to classify. I'm going to get rid of that 0 value. I'm going to change the color of my visible area. I'm going to change the opacity down just so I can kind of see what's going on. I'm going to turn off my Saratoga elevation. I'm going to bring my contour lines up a little bit so I have those. And now I can see, here we are, Johnson Tower, and I can see everywhere in town that is visible from this location. That is viewshed. And this is how to do viewshed with just one observer. It gets a little bit more complicated with multiple observers, but you follow the exact same path. All right, see you in the next video.